as many times as possible. So run the 1 down. So that's 2. So that's 1. 2 again. -2. -4. So that's 4. That's 8. -24. And that'd be 48 negative, which is 0. So that one, that gets us that. Now, because I know 2 has an even multiplicity, I know it'll at least work one more time. So I'm going to do synthetic division on this polynomial that's left, and I'm going to use 2 again. And it worked again. Okay. Now, I don't know for sure if 2 works 4 times, but it's got to work 3 times in order to work 4 times, right? So if I try 2 again, (14 times 2 is 28), I'm not going to get a remainder of 0, right? So that's 40. So that tells me 2 only works twice. That's what that tells me. Okay. So right now, we have x minus 2 squared. And then the polynomial we need to do some more synthetic division with is right here. 1, 3, 4, 12. What's the other place we know it crossed the x-axis at? -3. That should work in synthetic division there. And it does. So I get a factor of x plus 3. But I've got a polynomial left, and I don't have any other places that cross the x-axis. What is this polynomial that I have left? Set that thing equal to 0 and solve it. It's quadratic, right? So that gives us all the options for solving a quadratic, which are factoring, quadratic formula, square roots. We could do that on this one. Factoring won't work. I'll tell you that one on this one. Factoring is always an option, but it doesn't always work. Or quadratic formula will work. I'm going to use square roots because I've got just an x squared in there, so I'm going to move the 4. And then when I take the square root of both sides, don't forget the plus or minus on the side with the number. What's the square root of -4? 2i. Okay. Now my factor is x squared plus 4. So this is the factored form. Our zeros are x equals 2 with the multiplicity of 2 on that. X equals 3, and then x equals plus or minus 2i. There are our zeros for that. That is a -3. I'm sorry. I didn't put that. Thank you. So finding those zeros out of that, finding that factored form. Had that quadratic that was left factored, we would have had a different factored form there. So you've got to always look, see if it'll factor before you can do all that stuff. All right. So P over Q list, use it to help you with the graph. Use the graph to help you get started with your synthetic division. Keep in mind all those things that we talked about yesterday or the last couple of days with section 1 about multiplicities on zeros. If they bounce off the x-axis, it counts more than once. If it cuts through the x-axis, then it's got an odd multiplicity, and it could count once 3 times, possibly 5 times if it's a big enough polynomial. But the even ones are much easier to notice. So use those the multiple times and then go from there to kind of help you find the rest of them. Okay. So same exact thing we did in Algebra 2. It is not any different up to this point at all. It's all the same stuff. Okay. All right. Last thing in this section, or these two sections that we're actually doing together here, is building polynomials. Okay. When you build polynomials, they give us the zeros. So we did this in the first section. We're adding in higher degree polynomials here with complex or non-rational zeros to that. So when you're dealing with those, you've got to keep in mind the conjugate theorem that tells you, okay, if square root of 2 is a 0, we also know that the negative side of that is also a 0. So you get, sometimes they don't tell you about all of the zeros of that particular function. But case in point, degree 3 polynomial with zeros 5 and 3 minus 2. That's all the information they gave you. It's a degree 3 polynomial with a 0 of 5 and a 0 of 3 minus 2i. Because 3 minus 2i is a complex solution or a complex 0, we also know that its conjugate, 3 plus 2i, has to be a 0 as well. Okay? The same thing goes if they give you a 0 that has a square root in it. You know that it's got to be the opposite sign with it too. Okay? That's that conjugate theorem for zeros. Okay? So if they give you 3 minus 2i, you know 3 plus 2i is in there. If they give you 6 plus the square root of 7, you know 6 minus the square root of 7 is also a 0 out of that. Okay? It's the conjugate theorem tells us that that's what's going on. So building it is exactly the same idea. So we're taking a polynomial, degree 3, so we get the zeros. We know the zeros are 5, so that's x minus 5 as a factor. And then the zeros are 3 plus 2i and 3 minus 2i. So we have x minus 3 minus 2i, x minus 3 plus 2i. Set them up that way. And then I would multiply the stuff that has the i's or the square roots together first, because that all the square roots and the i's should cancel out when you get done. Okay, because you don't see a polynomial that has coefficients that are not rational and the i's are not rational. So when I multiply these two together, I want to do that part first. So x times x, that's the easy part. That's x squared, right? And then I distribute x to negative 3 and x to 2i. So that's negative 3x and positive 2ix. And then I'm going to distribute negative 3 to everything over here. So that's negative 3 times x is another negative 3x. And then negative 3 times negative 3 is a positive 9. And then negative 3 times positive 2i is negative 6i. And notice I'm leaving a gap there because I want to put like terms kind of in columns. The next thing is to multiply negative 2i times everything there. So negative 2ix. And then positive 6i. And then negative 2i times positive 2i would be negative 4i squared. And I put that underneath the 9 because what does I squared become? Negative 1. Negative 1. Remember the little chart? Square root of negative 1 is what I is defined to be. If you square I, it's like squaring the square root of negative 1. So that's where the negative 1 comes in. If you get I cubed, you're going to use negative I And if it's I to the fourth, that's 1. I to the fourth is positive 1. Okay. Now, so that's going to turn into a positive 4 right there, right? We know that that's happening there. And then you just combine those like terms. So we have x squared minus 6x. The negative 2ix and the positive 2ix cancel each other out. Same thing happens with the negative 6i and the positive 6i. And then 9 plus 4 would be 13. And then we still have the x minus 5 we need to multiply out here. All right. Distribute the x across. X cubed minus 6x squared plus 13x. Distribute the negative 5 across. That'd be negative 5x squared positive 30x. And then negative 65. Combine those like terms. X cubed minus 11x squared plus 43x minus 65. And we've built a polynomial that has degree 3 with those particular zeros to it. How can I determine if that's correct? I could graph it, and what will I see this graph doing? Where will it cross the x-axis? At positive 5. Will I see this stuff happening? No, because it's complex. So it should only cross the x-axis at 5. Okay, it shouldn't cross it anywhere else. It is highly unlikely that you multiply all of this stuff out and still get it to cross at the right spot if you messed up somewhere on the complex parts. It's highly unlikely that you got it all correct enough to get it to do the right thing. Okay, so you've got to be careful about that stuff and be mindful of the conjugate idea. Let's do one more and then we'll be done. Be in the class anyway. So let's do degree 4 with zeros at negative 6 and square root of 3 and one. What's the zero they don't tell us about? Negative square root of 3. Not a complex, just an irrational zero out of that. But we know that anytime there's a square root or an I in there, it came from a conjugate pair. So the plus and minus has got to be there. So factors for that. What's the factor for negative 6? X plus 6. I'm going to go ahead and get the 1, even though it's listed at the end there. So what's the factor for 1? X minus 1. And I'm just putting those two together because that'll probably be pretty easy to multiply together. And then the factors for the square roots of 3. Plus the square root of 3, x minus the square root of 3. Well, this one works out pretty nice because this is like a difference of squares. We know that the square root of 3's in the middle are going to cancel out. So we just say x times x and then square root of 3 times square root of 3. And that's going to give us x squared minus 3 is what that part multiplies together to be. And then we have, I can go ahead and multiply these two together if I want to. That's not a hard thing to do. X times x is x squared. Minus 1x plus 6x would be plus 5x minus 6. Now I have a quadratic times a quadratic, but still not too difficult there. I can just distribute x squared to everybody and then 3 to everybody and get get somewhere with that. So that'd be x to the fourth, 5x cubed, negative 6x squared, and then a negative 3x squared, a negative 15x, and a positive 18. Combine the like term in the middle there. F of x is equal to x to the fourth power plus 5x cubed minus 9x squared plus 15x plus 18. And we built a polynomial that crosses the x-axis at negative 6, positive 1, positive square root of 3, and negative square root of 3. So this one should cross the x-axis in 4 places because I don't have a complex 0. Anytime you got complex zeros, those do not cross the x-axis. Rational and irrational zeros do cross the x-axis. Okay, so this is 2 sections together, page 357, 11 through 32, and then skip a few in 39 through 72, and then on page 363, 7 through 4.
There's a UT Martin representative in guidance if you are interested in UT Martin, or if you want